All right, section 6.2 is about the graphs of the other trig functions, tangent, cotangent, secant, cosecant. I've mentioned before, tangent is really the only one of those four that's terribly important these days. So that's the only one we're going to spend a whole lot of time on in this video. So let's go ahead and plot some points for tangent. And I've plotted the ones that I want to plot here. So let's start in the middle at x equals 0. I've got my unit circle here for reference. So I'm going to graph tangent of 0. And let's see, we know that's sine over cosine. So I'm going to find sine of 0 and divide by cosine of 0. So 0 is over here on the right of my unit circle. And let's see, so sine is equal to the y coordinate and cosine is the x coordinate. So tangent of 0 is 0. So we're going to plot a point here at 0, 0. And then keep moving on. Let's do pi over 4, tangent pi over 4. Okay, so that's sine pi over 4 divided by cosine pi over 4. All right, and pi over 4, that lands me at this terminal point. Those are the same number. I'm going to divide them. Maybe you kind of see where this is going. When you divide root 2 over 2 divided by root 2 over 2, you just get 1. Okay, so tangent of pi over 4 is easy. We get 1. How about tangent pi over 2? I'm gonna have to move over here. Tangent pi over 2. Let's see, I'm up at the top of the unit circle here, 0, 1. So we're gonna have sine, which is the y coordinate, over cosine, which is gonna be our x coordinate. So 1 is the y coordinate, 0 is the x coordinate. That is undefined because we can't divide by 0. So this looks like those cases with rational functions where we get those vertical asymptotes, and that's exactly what happens at pi over 2. You can't find tangent of pi over 2. So we're going to throw in a vertical asymptote at pi over 2. All right, I've got 2 more points plotted there, negative angles. So let's think about negative pi over 4. Negative pi over 4 is going to start off at 0, go clockwise. So we're going to land down here in the same place that we get for 7 pi over 4. All right, so tangent of negative pi over 4 is sine over cosine again. All right, so we've got the same root 2 over 2 over root 2 over 2, but down in the fourth quadrant, one of them is negative, one of them is positive. So when we divide, you're still going to get 1, but it's going to be negative 1 because we're down in the fourth quadrant. All right, so the y coordinate at negative pi over 4 is going to be negative 1. All right, we got 1 more point to plot. That is negative pi over 2. So let's figure out the tangent of negative pi over 2. Okay, so sine over cosine. Negative pi over 2 is going to be the same spot down here as 3 pi over 2. So again, we're doing sine over cosine, y coordinate over x coordinate, negative 1 divided by 0. We have found another asymptote. Yeah, so any place that cosine is equal to 0, tangent is going to have a vertical asymptote. So that's not a whole lot to go off of. Let me fill in the shape as best I can, and then we'll have Desmos kind of correct me a little bit later, as always. There we go. It's got a curve too. It's not completely straight there in the middle. It is obeying those vertical asymptotes. Kind of has a snake-like shape, a little bit like the x cubed graph. It's actually a completely different shaped graph. Tangent goes to a perfect 45-degree angle just for a moment there when it crosses the origin, whereas x cubed goes almost completely flat there at the origin. But it does kind of have a reminiscent shape to it. All right, here we are in Desmos. We're looking at the graph of tangent, and that does sort of look like what I drew there with those vertical asymptotes at pi over 2 and negative pi over 2, and that sort of snake-like shape in the middle. But tangent is periodic, just like sine and cosine. So it has this shape, but it keeps repeating it over and over and over again, forever and ever and ever in both directions. Okay, so it is periodic, just like sine and cosine. But its period is a little bit different than sine and cosine. Remember, sine and cosine took from 0 to 2 pi to repeat their shape. If I look from 0 to 2 pi here, it looks like I've done the complete shape twice. It turns out that the period of tangent is actually just equal to pi. All right, again, you can see that the period of tangent is just 1 pi instead of 2 pi. It takes up pi over 2 in this direction and another pi over 2 distance in this direction. So the period of the tangent function is pi. And then if we get a coefficient on the x on the inside, so if you have tangent of, I think we had b as the coefficient for our sine and cosine. The period of this function, just like for sine and cosine, we would say 2 pi divided by b because 2 pi was the original period. This would have the period of pi over b, whatever that number is. All right, so here I have given you the most ridiculous tangent function that I could think of, and I've asked you to calculate the period of it. And again, the period is only determined by the term with the x on the inside. So we're going to completely ignore the negative 24 minus 7 plus 3. We're just going to focus in on that coefficient. So this 4 is my b in that formula. So our period is pi over b. Okay, so 2 pi over b for sine and cosine, pi over b for tangent. So we're going to say the period is pi divided by that b, which is 4. That's all you have to do for this one. So we've already looked at the graph of tangent. I'm just going to show you the graphs of the other ones just so that you will have seen them. Of course, we always say sine, cosine, and tangent are our most important trig functions. So here's cotangent. It kind of looks like a flipped upside down tangent graph. It's got different asymptotes. Tangent had its asymptotes at every odd pi over 2 multiple. Cotangent, because it's got cosine over sine in the denominator, it's going to have its asymptotes whenever sine is equal to 0, which is going to be your multiples of pi, 2 pi, negative 2 pi. All right, cosecant, remember this is 1 over sine, and it doesn't look like any of the other graphs at all. Kind of has a U shape, a repeating U shape. And this graph has an important relationship with its parent function, sine. So if I graph sine, look at the relationship between sine and cosecant. Okay, so cosecant kind of seems to be bouncing off of the maximums and minimums of the blue dotted sine graph. And look at the asymptotes. The asymptotes of cosecant happen wherever sine has an x-intercept. Okay, so any place that the sine function crosses the x-axis, that blue graph at like pi and 0 and negative pi, that's exactly where cosecant kicks out an asymptote. All right, let's try secant. Secant looks a whole lot like cosecant, just shifted over because sine and cosine look like each other, just shifted over. And again, if I turn on cosine, because secant is 1 over cosine, you can see that it does the same thing that cosecant did with sine. It bounces off of the maximums and the minimums, and anywhere there is an x-intercept, it kicks out an asymptote. All right, so that's all we need to know for the graphs of the other 4 trig functions. Just know what the shapes look like and be able to calculate the period of a transformed tangent graph.